Hello friend, today we will talk about maximum likelihood estimation, that is likelihood estimation. So what it is and how many parts of this are. So what do we mean by this term? So we will just discuss about it first. Now, method of maximum likelihood is such a method by which we can obtain such a good estimate. In this method, a function called the likelihood function is to be constructed. We define this for two cases. That is, the first one will be the discrete one. It will be discrete one, and the second one will be the continuous one. Okay, so we'll first see our discrete and then we will see the continuous one. So let's begin. For discrete one, let x be the discrete random variable which describes the population. Here we are taking x as the discrete random variable, that is rv. Now we are taking x1 x2 up to xn for our random sample draw. So we are taking this whole set for the rs, that is the random sample, and in this let x contain theta 1 theta 2 up to theta k, that is the unknown parameters. These are unknown that is unknown parameters. So the probability for p at x equal to xi will be the fxi theta 1 up to theta k. That will be the PMF, that is the probability mass function for that probability, where x is what? X is the discrete random variable, and xi is the one of the set among the rs, one of the member among the set rs. Here you can see it clearly. Here the probability of x is equal to x1, x equal to s2, dot dot up to xn. We are having some function that we will call it the L. That will be the likelihood function, that we call it by L, capital L. So here you can see the likelihood of x1 x2, the whole set, and here we are having the two parts. This part is the rs and this part is the parameters, unknown parameters. They are divided by using a semicolon here, and this will be the probability of as it is independent random variable, so we are taking it probability product. In form of the product, we are taking x1 is equal to x1, x2 is equal to x2, and we are having the product of all these terms. Now what happened then probability of x equal to x1 will be this. Likewise probability of this will be this. How? Because we have talked about it earlier, that probability of x equal to xi will be the fxi will be the, and all the unknown parameters, the function of unknown parameters. So the product of these will be the value for the likelihood function. This one is for the discrete one. Now let's talk about the continuous form. For the continuous one, we are having the same thing. X will be the continuous random variable, whereas in our earlier one we are having x as the discrete one. Now unknown parameters will be the same, and where the function, here the function will be in this way. Earlier we are having function in this way, as you can see, fxi and the unknown parameters, but here we are having function in this way. Here x will be inside of the function, and if this is the condition, then we can easily calculate this, where the probability of x1, we have x1 will be under x1 and a small change in x1. In between of this, x1 is present. Like this, x2 will present in between x2 and x2 plus a small change in x2. In this way, we can write it, as you can see here. It is in between xn and xn plus dxn, the xn. Now, as they all are independent, so we can write it in the product form. Each here we are having dot dot, we can write this in product form. Now what we are having here, we can write it as the probability. We can convert it as in the function format, as we have seen here. Function, this will be the PDF, that is the probability density function, and in the earlier one we are having PMF, that is probability mass function. These two things should to be remembered well. We were doing the sums for the continuous and the discrete part, so it will be the function of this into dx, and likewise this into dx1. So this will be the likelihood function for the continuous part. So thanks.